Dear ladies and gentlemen, members and friends of the Swiss Chamber of Commerce and Industry, welcome to a new edition of our lunchtime webinar. My name is Stefan Aebi. I'm member of the Executive Committee, and I'm speaking to you from our Swiss Chamber online environment here in Japan. On the contrary, our guest speaker today is based in the United States, more precisely in the state of Maine, which is to the very east of the continent and where it's now late Monday evening. I have the honor to now introduce Ms. Annette Bossler, who will talk to us about biomass power, what is considered as a growing power generation source in Japan's changing power market. Annette Bossler is the Managing Director of Maine International Consulting and also Senior Market Intelligence Expert at FutureMetrics, a leading consultancy in the wood pellet sector. FutureMetrics provides information, analysis, operation guidance, due diligence services, and strategic advice to many of the world's leading companies who are in the wood pellet sector or who are considering entering the sector. The company also is supporting numerous Japanese clients. Ms. Bossler has over 25 years of experience in the international business development for private and public entities. One of her focus markets is Japan. She's been monitoring the Japanese energy market since 2010, especially with regards to renewable energy and the ongoing power market reform. She holds an MA honor degree in Japanese studies and public international law from Bonn University. Okay. Time to get started. Let me now hand over to Annette Bossler. Please enjoy the presentation.
Good evening from Maine. Hello, Tokyo. Thank you for the introduction, and thank you to the Swiss Chamber of Commerce and Industry in Japan for giving me the opportunity to share some information with you today and some thoughts. I also like to thank my colleague and friend Markus Queller of GNS Asia in Japan, who created several years ago this connection, because otherwise you might wonder, why does somebody in Maine present at the Swiss Chamber of Commerce? So Markus Queller, thank you again. So I'm presenting today in my role as Senior Market Intelligence Expert at FutureMetrics, as Stefan Aebi outlined. So we are a company. We provide economic as well as technical due diligence and feasibility studies for the wood pellet sector. So we can do both economic analysis, market analysis, but we also have technical team members who actually can either go visit a pellet plant, do due diligence for an investor, or can improve efficiency in operations. So we cover the entire supply chain. This is some examples of our clients, including obviously some clients in Japan, but also clients in North America, South America, and in Europe. So I'd like to start with just going back to what we've seen happening in the Japanese electric power market over the last more than 10 years. So up to 2011, so up to Dai Shinsai, we basically had the 10 Japanese utilities controlling the market. Nuclear power played a major role in power generation. There was pressure by the government then to increase or improve nuclear safety, but as TEPCO regularly said, oh, lights will go out in Tokyo if you force us to make any changes here. Obviously, that very strong position by the utilities changed with Dai Shinsai, and the government, Japanese government, went ahead with another go at reforming the power market. So a big part, obviously, of the power market reform was that in July 2012, feed-in tariffs were introduced for renewable energy. That especially created a major solar PV boom, because at the time was 42 yen per kilowatt hour. That was by far the highest and most attractive feed-in tariffs for solar PV power in Japan. But also the feed-in tariffs for wind and also biomass were pretty good as well. What happened though, when the the renewable energy feed-in tariffs were first launched there was not, compared to, for example, Europe or North America, there was not that much process behind it. So, for example, to file your application for your project to be certified under the feed-in tariff, you did not have to submit a line study. You did not have to submit a business plan or prove that you had the financial capacity, capabilities, as well as site control. So that led to, in a way, a bubble in that many projects were being certified for the feed-in tariff, but actually were not built. It also made it very, very challenging for the utilities to plan their power grid capacities. And on the one hand, they were told, yeah, you have all this renewable energy power go online, but then there was a lot going online, but not as much that was being certified. In any case, it has pushed the power grids to the limit, especially in parts of Japan like Kyushu, which is why the market is also moving to a new grid, power grid management system. In addition, you have basically now that both industrial as well as private customers can select their power provider, and that has also opened up the market. There are now more than 900 companies that either generate power and sell them to utilities or to other customers, as well as retailers for electricity. So overall, on the renewable side, as of the end of last year, Japan had a total of 63.4 gigawatts of renewables capacity that was operating or is operating. As you can see, the vast majority is solar PV. But then there are about 4 gigawatt of biomass power. And what is going to happen in the next several years is offshore wind power as well. There's a project pipeline of over 15 gigawatts that's being in the planning. Another major factor that will drive especially biomass power development in the future is the capacity market that basically started this year. So capacity market basically provides opportunity for a power plant to be ready to provide specific amount of power when needed, either because there's demand or because it's required for grid stability. That capacity market so far has not existed, but it's starting up now, and it's another opportunity for power plants in general, but also biomass power plants to sell power into the market. So what does power generation in Japan actually look like over the past 10 years? Obviously, you see that up till Daishinsai, up until March 2011, obviously nuclear played a major role, and the nuclear power plants obviously were stopped, and you saw a spike in the use of fossil fuels. So that is basically coal, liquefied natural gas, and oil. And those were reserve power plants that most industrialized nations have, is power plants that normally don't run or run at very limited base, but if there's a major emergency, then they kick in. So Japan actually got through this major shift by obviously conserving energy, but also, switching on, basically running their reserve power plants. So by the end of 2019, renewables, if you include hydropower, which Japan has had quite a bit of even before Daishinsai, they now apply roughly 20% of Japan's power demand. The existing Japanese government plan basically has a target of 22 to 24% renewables by 2030. So basically, that's close to being achieved already, and I think we're all looking forward to the new government strategic energy plan that's supposedly coming out sometime this year to see if the target is being revised. So when we talk about biomass for electricity generation, what does that actually mean? Biomass can come from different things. It can be garbage or trash, as we say here in America. It can be different crops. It can be yeah, different alcohol fuels. It can be landfill gas or other biogas, and obviously wood. And our focus today is mostly on woody biomass and a little bit on crops, because we are going to talk a little bit about PKS. So when we talk about wood, there's always the question, well, can the use of wood be sustainable? And there's a forest management, there's good wood and there's bad wood. You know, it's like with everything else, any energy source, if it's done right, if it's done well, it's sustainable, or it's less harmful to environment. If it's done without any system, any control, it causes damage. So if we're talking about good woody biomass, it comes from forests that are sustainably managed. That means that whatever you harvest, you replant after several years, you thin out, because you take out a few trees so that the remaining trees have enough space and air and sunlight to grow. And then eventually you harvest the trees. This is what sustainable forest management looks like. Sustainable forest management also means that you're not clear-cutting entire huge land areas. You are planning your harvesting. Yeah, so if you are a larger landowner, or you are an entity that leases forest areas, you have your areas and you plan your harvesting. So you always have an area where you harvest and then you replant. And this is what this basically looks like. For wood products, not only for woody bioenergy fuels, but you have different sustainability schemes and standards, and these are some of the acronyms. I won't bore you with what all this is, but basically the wood industry and lumber industry in general has sustainability standards where it is good companies, good players in the market make sure that the wood that they use comes from sustainable managed forest. So wood and wood fiber products, we use them every day. We use them for home construction, for printing, presentations. Yeah, toilet paper was a big topic in this pandemic environment. Yeah, there's forest fiber in the face masks, that we wear. So wood products are all around, and most of these products, or basically all of them, fall under some type of sustainability guidance and regulations. So when we talk about woody biomass fuels, we're basically talking about wood pellets and wood chips. So wood pellets is on the left here on the image, and chips on the right. Wood chips can come either from harvested trees, but there can also be a byproduct, a waste product from wood that was, for example, used in the furniture industry or some other industries. Wood pellets are also manufactured from lots of different wood parts, but they are specifically manufactured for energy use, whereas wood chips is a major product for the paper industry. Wood pellets are specifically managed for energy use, and they normally be sold under long-term supply contracts. And that's very, very important, because it is the confirmed supply contracts that make a biomass power plant a bankable project. If you apply for financing with an investor or a bank and you cannot show where your fuel supply is coming from, you will have a tough time getting financing for your projects. So wood pellets in particular use part of the tree that is not being used for anything else. So it can be sawmill residues, so sawmill that saws your lumber for home construction. Yeah, that's basically trash, so that pellet mills buy that. Or the wood thinnings, what we talked about 2 slides before, when you have trees that you have to cut so make room for the remaining trees to grow. It can be low quality wood. For example, the Canadians have had their fair share of wood pests, and they've basically used, trees that were damaged by different insects that you could not use for paper, high quality paper or other high quality wood products. You can use them to make pellets. It's a topic that's being discussed in Germany right now because they have over 32 million cubic meters of bark beetle in damaged wood. It can be limbs. So what the good pellet producers avoid using is full saw timber. Yeah, that is high quality wood that can be used for a lot of other more high value products, and then later either the waste wood from the manufacturing process can be turned into pellets, or when that product, whether it was a housing or some other lumber product, is at its ends of its use, it can be turned into pellets. The other biomass that is having a fairly sizable role in Japan is palm kernel shell, or PKS. That is basically a byproduct from palm oil production. It comes mainly from Indonesia or Malaysia. It is sold at spot market price or short-term contracts. It's therefore not a bankable fuel. It's a cheap fuel, but it's not, because it's a byproduct, and unlike pellets, is not made specifically for power generation. Yeah, it's something that you can buy as an add-on fuel, but you would not really plan a total power plant to be fueled with palm kernel shell. PKS is also quite controversial because, again, like with woody biomass, you have palm oil farms, plantations that have a sustainable management, and then you have sort of the Wild West PKS farms. And so to basically make sure that the PKS that's being brought into Japan comes actually from sustainably managed palm oil farms is a challenge, is quite a controversial subject, is actually a topic the Japanese government is trying to introduce more regulations. Woody biomass for energy is also covered by World Trade Organization rules. But in essence, WTO still allows every country to create their own sustainability requirements. And that's especially important in Europe, where some European countries, especially in the UK, but also in the Netherlands, there is coal plants are being converted to either run 100% on woody biomass or have woody biomass portion replacing some of the coal. And that is to reduce CO2 emissions. So in Japan, how does it work in terms of where does the power, how does the power generated with biomass power plants actually get sold? The way it works in Japan is the feed-in tariffs were launched in July 2012. Every year there's a METI pricing committee that sets the new tariff for any new projects that apply for new certification. So if you got your feed-in tariff for your project in 2012, and a few years later you commission your plant, but you applied for it in 2012, you get the 2012 tariff. If you applied for feed-in tariff certification in 2017, you get the 2017 tariff. So as you can see, it started off with basically only 3 different categories. So biomass, which was only forest thinnings, and that means mostly domestic Japanese wood for biomass power plants above 2 megawatt, got 32 yen, good price. Yeah, for roundwood, 24. And you already see that the government already right off the beginning said, look, we don't want roundwood or biomass from roundwood being fired. We want to use that for higher value products. And then you got a different price for construction debris. So that has evolved over time. So the government introduced a special feed-in tariff for small biomass power plants up to 2 megawatt, and those are mostly plants in rural areas in Japan that use local wood and biomass supplies. And it's as much an energy promotion aspect as it is an economic development to revitalize rural communities and use the woody biomass that's available in those areas. And then in 2019, for larger projects, the government basically stopped the confirmed flat rate 20-year feed-in tariff and switched to a tender system, just like they had done in 2018 already for solar PV. So when we look at the tenders, again, it's still fairly new. So the first tender was in 2018 for 180 megawatt. What the government does, they have a ceiling price, or the maximum price that a bidder can put in, but they don't disclose that. So you have to be second guessing what it might be. And there was basically only one winning bidder that stayed below the 20.6 yen per kilowatt hour, which was Soma Kyoto Power. But then they basically canceled their bid because they decided to wait until this year to then bid into the capacity market, because they will get more per kilowatt hour. The second tender was in 2019 for 120 megawatts biomass power. And the big difference there was that the government no longer allowed projects that used PKS, or palm oil or palm trunk, as fuel. So this was to be as fuel. So this was a fully 100% biomass, woody biomass tender. And but nobody won because all the bids were above the undisclosed ceiling price of 90.6 yen per kilowatt hour. And the reason also why there were so few bids is because a lot of the projects, they applied for their fit, and so they have their fit price already there. At this point, don't need to go bid into the tender to get to be able to sell that power. But obviously, that's going to change over the next several years. So there were also a number of coal plants that co-fire biomass. And so if you have a coal plant in Japan and say you applied for the feed-in tariff for biomass, say in 2015, 2016, for that portion of biomass generated power, you get that feed-in tariff. And what the government did in 2019 was to make sure that that ratio stayed the same, and so that the coal plants that co-fired did not basically then replace that again with back to coal. So, but you do have a bubble, just not as extreme that you have on solar PV, but quite sizable. And so that basically means you look at this number, you had more than 6 gigawatts of biomass power that these were project owners that applied for receiving the feed-in tariff, but a lot of these projects were never built. So what was actually built and commissioned was 585 megawatt until the year end of 2018. And by the way, this is 100% biomass fueled project, so this does not include co-firing. So what the Japanese government has done is basically last year said, okay, out of these over 6 gigawatt of projects, plants or project management teams that have not ordered their equipment by March 2020, so March this year, they have basically lost their FIT certification. They then have to go through a tender or go to a tender in the capacity market. So similar to what was done on solar, the government is trying to sort of let the air out of the bubble so that whatever is in the project pipeline is actually real projects that will actually be built. So where does biomass fuel in Japan actually come from? So starting with domestic biomass, what is being used in the various biomass power plants can be wood thinnings, Yeah, and again, this is all domestic wood, and you see that that portion has been increasing because it's a very attractive feed-in tariff, especially for power plants below 2 megawatt. Then you have lumber mill residue. Again, a lot of the small, especially smaller lumber mills are in rural area, so they will have sawdust, they will have waste wood that can be used. Quite a bit of these plants use construction waste. Few use imported wood chips, though those are often waste wood or leftovers from the paper industry. So the challenge with domestic biomass supply in Japan is that Japan has actually a lot of wooded area, but the land ownership is very, very fragmented. So for example, you have 27% of private landowners own less than 5 hectares, and another 28% own between 5 and 10 hectares. Those are very, very small plots, and that make forest management and forest harvesting, including building infrastructure like logging roads and transportation infrastructure, very, very tricky and expensive. So could Japan theoretically use more domestic woody biomass? Yes, they could, but they would have to further come up with incentives for all these many small forest owners to work together and to combine wood harvesting to make this efficient and cost efficient. Another major biomass fuel is imported wood chips. And it's quite interesting when you look up the total amount of imported wood chips into Japan, it was over 12 million metric tons in 2019. However, a vast majority of this goes to the paper industry. So it's about, in 2019, that was 7.5 million metric ton. And then we worked out that about 3.1 million metric tons of wood chips actually go to the particle board manufacturers. So your plywood boards and the different boards that also being used in construction. So the wood chips that theoretically are available for fuel use are about 1.4 million metric tons. And we think there's probably close to that amount is actually being used for biomass power generation. PKS, the palm kernel shells. So basically they come from Malaysia and Indonesia. Indonesia is by far the largest supplier. The cost has been fairly stable, though Indonesia keeps adding special tax. That used to be 5 and then 10 and recently $15 per metric ton of special tax to any metric ton of PKS being exported from Indonesia. But it is compared to wood chips or wood pellets. It's a low cost fuel source, and also because it's in Asia, the transportation costs are a lot lower. Wood pellets. So wood pellets used to come predominantly from Canada. Canada used to be by far the largest supplier, but was overtaken by Vietnam in 2019. And so far, Vietnam looks like being on track and probably, again, being the #1 supplier. The reason for this is, Vietnam has a large furniture sector, so there is wood and waste wood there. Obviously, the logistics and transportation is a lot closer than, for example, bringing in pellets from the west coast of Canada. There are obviously concerns about whether all the wood used for wood pellets out of Vietnam is really sustainable. And that is another major discussion topic in Japan right now. So if you look at the cost, you see the big difference in price compared to, for example, PKS. And again, you see that the Southeast Asian supplies, especially Vietnam, is much lower than, for example, pellets out of Canada. Australia has started to enter the market. There's also a number of pellet mill projects that are in planning because they also see that this is a segment they are interested to get into. So who is using what in terms of biomass fuels in Japan? Not all power plants really disclose in detail what they're using based on what we know. So out of the 125 coal plants that are currently operating in Japan, about 68 are co-firing with some sort of biomass. And among the 20 that are being planned to be built, about 7 plan to do co-firing. So that's a sizable number. What are they using? Again, not all of them disclose, but there are quite a few that use some type of woody biomass, and that can be domestic or important. Quite a few use PKS. A large number uses wood pellets, and that's because wood pellets are, if it's an ultra supercritical technology, coal plant is very easy, without any major technical adjustments. You put in wood pellets instead of coal, or they have another biomass mix combination. So, and the coal plants in Japan that applied for the feed-in tariff for the portion that they're co-firing are getting that amount of money. It's the same for that co-fired portion as, for example, 100% biomass fuel power plant gets. So that was one of the major reasons why coal plants decided to get in the co-firing. This is the project pipeline for biomass power plants that are using basically 100% biomass fuels, and you see there's a lot of capacity. So over 1 gigawatt being commissioned this year. And again, this is because these people have to make sure they get their plant built and started, commissioned, so they don't lose their fit. And then still quite a few more projects going online in 21, 22, 23. Anything being commissioned in 2024 onwards, they will have to go through a tender process in order to sell their power into the market. So if we look at the 100% biomass power plants, it is similar there. It's a mixture, can be wood pellets or wood pellets PKS. And again, a lot of the plants don't really disclose what they are using. And again, you see wood chips is quite a popular fuel. Part of the reason is that a number of the biomass power plants that use wood chips are actually owned and operated by paper companies or are next to paper companies. So they get waste wood from the paper manufacturing, generate power, and in some cases also generate heat that's again being used in the paper manufacturing process. And going forward, you see that, wood pellets, there's a few more biomass power plants coming online with wood pellet use or wood pellets and PKS. Import locations in Japan for wood pellets are predominantly Tohoku, some in Kansai, some in Kyushu, and that is because this is where a lot of the plants are. Challenge in Japan is Japan has ports, don't have really an infrastructure right now for wood pellet import. Wood pellet need to be stored in a covered, closed environment. You cannot just pile them up in heaps because they will absorb humidity and then cannot no longer be easily processed and fired. There's right now only one port in Japan, it's in Yokkaichi, that recently opened a woody biomass, including pellet storage facility. So logistics in Japan for wood pellet import are still have to be quite sophisticated and well planned so that when the vessel arrives with the pellets, they get transported very, very quickly to the power plant where they can be stored in the right way. So at FutureMetrics, we constantly get asked, what's the demand? Yeah, what is what is the amount of wood pellets in Japan going to be like? And we get these questions obviously from power plant operators, from pellet suppliers, but obviously also from the investor community. So if we go by the current project pipeline, and we're assuming that PKS will be less popular because of new sustainability requirements set by the Japanese government, we're assuming that by 2025, you could look at more than 9 million metric tons per year of wood pellets imported into Japan. That's one of our scenarios. But that will also depend on how the average, yen per kilowatt hour price for biomass power is going to develop. We saw in the tender, so the past ceiling price was 19.6 yen per kilowatt hour. What we did, we have this ability to pay dashboard where we can put in different metrics, so the pellet price, but also transportation cost, shipping cost, in Japan cost, and basically work out, okay, the delivered cost to plants per metric ton is X. What is my feed-in power price going to be? Does it have to be in order for the biomass power plant to be profitable? So if, for example, we use the estimation that it's $3,000 capex per kilowatt of capacity, so that's what you're going to invest for your building your biomass power plant, you can still make money at 19 yen per kilowatt hour feed-in tariff, but your supply chain and logistics costs have to be really well managed. If you are above $230, CIF at the plant cost, you start losing money. Obviously, that gets even more challenging if we use a scenario of $5,000 US dollars capex per kilowatt. Basically, you need to have at least something like 21 yen per kilowatt hour to make money. Or for some reason, you have to get the cost down, which again, if you want to buy good biomass and biomass from sustainably managed forest, that all comes at a cost. And then again, with $8,000 capex, it's basically unless you go into the capacity market where you can get more than 24 yen per kilowatt hour, it's not a worthwhile business anymore to be in. So at FutureMetrics, we can run all types of scenarios. We also have run scenarios, for example, if a certain amount of Japanese coal plants were increasing their biomass share or switching to 100% biomass, what would the demand look like, and also what are we looking at cost? So this is going to be the interesting question. If the Japanese governments can keep the biomass power price at a certain level per kilowatt hour, and the supply chain, obviously on the supply side, but also on the Japanese logistics side, can get the cost down, yes, we will see continued use of biomass power in Japan. If these things don't work out well, then yeah, that could be challenging times for the sector. So concluding, we at FutureMetrics believe that there is a long-term future for biomass power that can be, especially in the capacity market. We also think that the renewable energy targets overall are on the conservative side, so they are achievable. And wind and solar, obviously intermittent renewable energy sources. Biomass power is non-intermittent. It can be used as a base load provider. And with nuclear power plants disappearing, and Japan also eager to reduce its CO2 emissions to meet the Kyoto and Paris Treaty targets, biomass power can play a major role. But it also will depend, obviously, on suppliers to manage capacity and cost. And Japan has to invest in infrastructure and logistics, especially for pellet import. That is, I think, one of the key questions. If you look what Japan has done on the liquefied natural gas side, they have built a lot of LNG terminals. They make that happen. If the government views biomass power as a long-term base load power provider, then I think we will also see increasing investment in the logistics side as well. And then this could be, Japan could become one of the largest biomass power markets worldwide. So if that has whetted your appetite on this topic, you can buy a full report on our website. And I thank you for your interest, and I'm happy to answer questions, or at least try to.
Ms. Bossler, thank you very much for this deep insight into the biomass and wood pellet market in Japan. Thank you very much also for agreeing to answering a few questions from our audience. Actually, it seems that a lot of people were inspired to ask questions. So let's just get started. First, it seems that our audience is very diverse, from a lot of experts in the field, but then there is a few lay people, like also myself, who don't really see or didn't know much about biomass and wood pellets before your presentation. So what I was first wondering, in Japan, a lot of garbage gets put on a ship and exported to whichever country where it magically disappears. But you mentioned in the beginning of your presentation that also garbage could be used as biomass fuel. Why is it that this is not happening in Japan?
Actually, Japan has, I don't know the number of plants, but Japan has quite a few waste incineration plants. I actually recently saw document by the government, given some guidelines how to deal with like face masks and waste like this in waste incineration plants. So there are some plants like that, but that's a totally different fuel category. Again, if you burn waste, you have to sort waste. And again, if it's waste that, for example, contains plastics or other substance, you have other challenges. You have to do emission control. It's while it sounds similar, okay, you throw something in a boiler and that drives a steam turbine. The material and the emissions and the whole technical aspects are quite different, but there are waste incineration plants in Japan. There's just more waste than what can be processed in Japan.
I see. Thank you. So there was one question also on this co-firing of biomass with coal, and how is the influence of co-firing instead of just burning pure coal in terms of CO2 and methane, if you put it in relation to the unit of electricity that gets produced with it?
Okay, I can't tell you off the top of my head with the CO2 emissions of the biomass portion, but it is less than on coal, which is, for example, one reason why Drax Power in United Kingdom, they several years ago switched an anti-coal plant to biomass. And it may be that some Japanese coal plants are going to look at that, because you cannot do this with every coal plant. You need a specific technology. So the so-called ultra supercritical coal plants that have certain type of boiler, they can, without major technical change, they can fairly easily switch to biomass, and there's reduced CO2 emissions from the biomass than compared to coal. In addition, you can, in some cases, you can actually improve the efficiency of a coal plant, which is another thing that the Japanese government is looking at right now, because you may have seen a few weeks ago, they announced that they want to about 100 old coal plants in Japan to be decommissioned because they're less efficient and they have more CO2 emissions. There may be some candidates among those 100 plants that could actually extend their lifetime if they switch to biomass.
Thank you. Do you see also that the Japanese government will continue with a preferential feed-in tariff for biomass, although most of the biomass, as you mentioned, is actually imported?
Well, that is why part of the reason why they have switched to tender for really large project, because the large biomass power project, and we're talking power plants that have 40, 50, 60 megawatts of capacity. Those power plants mostly use imported biomass. And again, it's a fairly sizable capacity, and the government is very, very eager to get the cost down, just like they've been pushing the cost down on solar and on wind. On the really small plants in rural Japan that mostly use domestic woody biomass, I expect that the high feed-in tariff there will continue because of the rural economic development aspect.
So given the current world situation, as you just mentioned, there was doubt in our audience about the current world situation with whole importing and exporting stops and difficulties due to the pandemic. Are most of the projects still ongoing, or is there maybe a halt or a stop in certain plants?
Because on the fuel side, these plants have long-term agreement, and fuel has been supplied into Japan. I mean, there were, if you look at what's involved in harvesting trees and making, for example, pellets or wood chips, this is not like working in a meat factory where people are working very, very close together. So there's been less impact there. There has been a little bit of impact in terms of people, for example, quality control people, everything not being able to travel. And in terms of some new plant projects, there are some delays because of plant equipment, or engineers not being able to travel. But on the pure fuel supply side, there has not been any impact.
So we won't see any breakdown of the production or of electricity anytime soon, I hope.
I don't think so.
And one more thing that you also mentioned in your presentation, the storage of the pellets, or like the whole imported or also locally produced wood, is very difficult, also because it has to stay dry. And one person from the audience is asking, so pneumatic conveying in closed pipes has apparently many advantages in terms of dust and explosion control. What will be the future for the mode of transport and the storage of the wood pellets? Do you have any insight on that?
Well, it's a good question. Well, I think if biomass power in Japan using pellets continues to grow, then it makes sense for investors to really build more storage facilities. And some could be like, for example, if it's the power plant very close to the port, yes, you could look at conveyor system or pipe system to basically automatically transport the pellets to that plant. But those are investments that still need to happen. Again, it depends on the long-term outlook and also the power cost development, whether that will happen or not. Again, the other option is there is technology being developed. I mean, there's a number of players around the world that are looking at torrefied pellets that are, less prone to, absorbing humidity. And then there is steam exploded pellets. That's a pellet that you could pile outside like coal. But there is not yet large scale. There are not yet large scale production plants that make these type of pellets. That's the other thing. Again, if not only Japan, but also in Europe, if the market overall continues to grow, you're going to see probably much more steam exploded pellets.
So large investments involved on either side. I see. So in the talk that we had previous to this webinar today, you also mentioned that there is a lot of doubt in the general population about the ecological side of biomass. And I also saw that there is a lot of people being very critical in our audience today. Is biomass wood pellets, is that just a thing for investors, or is it actually more ecological?
Again, it depends how it's managed and where it comes from. For example, one reason why Canada is such a large supplier to Japan is because Canadian forests, the vast majority of Canadian forests are sustainably managed. That means what is harvested is being replanted. That's, by the way, the same we do it here in Maine. It's also what happens in many European countries, including Switzerland, Austria, and Germany. If it is done that way, woody biomass fuels are sustainable fuels. However, yeah, they are, like in any sectors, they are the gold diggers or the black knights that basically buy wood from where they do not know the source, or they don't want to know the source. Where forests are just being clear cut, with impact obviously on habitat for wildlife, or where arable land is being converted to forest. That does happen. That is also there. I mean, there is no, oh, this is perfect. Yeah, it's like with solar PV. You can have good, well-engineered solar PV plants, and you can have solar PV plants that were put on a hill in Japan without any geotechnical investigation, and the next typhoon comes and the whole park washes down the hill. So it's reputable providers and suppliers, as well as reputable customers in Japan, do make sure that the wood is coming from well-managed sustainable sources. And as I said before, it's the insect-infested damaged woods. I mean, what is Germany going to do with 32 million cubic meters of bark beetle damaged wood? Paper industry doesn't want it. Furniture industry doesn't want it. Probably one of the few sectors that will say, yeah, we'll take it. It's going to be the biomass fuels industry, because you have to cut these trees down. Otherwise your infestation gets even bigger. So it's like with everything. It is how it's managed and if it's responsibly managed. But yeah, are there black sheep in this sector? Yes, there are.
In Japan, it would probably also be used to produce one-way chopsticks.
For example.
I think we could go on and on with a lot of other questions and the discussion on this topic. Just one last question before we have to close the session. What kind of steps are biomass plants in Japan taking to reduce the environmental impact of their firing?
Basically, they have to go through emission control. They have to comply with emission control regulation in Japan. They have to go through an environmental impact assessment, like any industrial plant. Basically, you have to say, okay, here's what our emissions are. Actually, if you look at permitting documents for biomass power plants, if you go on the Kankyo website, there's actually a database. You can look up any industrial or energy project in Japan and where it stands with regard to environmental impact assessment. And if you look up the biomass power plants, you'll see their reports on, what the emissions are, and there's public hearings and everything. So it's actually quite a strict process.
That's good to know. Sounds very interesting. I might actually have a look at some data then as well.
I could send you the link. And again, if there are any other questions,
Perfect.
if you want to email them, I can get back to people.
Thank you very much. So with this more positive note for the end, I would like to thank you again very much and move over back to Stefan Aebi for a few closing remarks. Thank you very much.
Hello again. Many thanks, Annette. I enjoyed very much listening to your presentation as well. Learned a lot about biomass energy. Thank you very much for your presentation and also for staying up so late at your side. So have a good night now. So that's it for today. Thank you very much for joining and have a good day. Bye-bye.
Thank you. Bye.